Good morning, Dr. Barus and Professor Nemai. My name is Quang Minh Tran. My partner is Matt Lê Nguyen. We are pleased to be presenting our project, the bidirectional DC-AC inverter, to you this morning. The goals of our presentation today is to introduce you to the inverter basis. From then, we will show you our implementation of hardware and software, and our result, and then our findings. So first, what is an inverter? Inverters are essential in today's world. They convert DC power to AC household power for running electronic equipment and appliances. Depends on the type of output waveform and mode of operations. Their price can range from several hundreds to tens of thousands of dollars. The goal of our project is to design and construct a pool sideway inverter to be used in the high power lab. Our inverter can work in both standalone and grid tie modes. It also has the ability to control and regulate the output current. One special aspect of our inverter is that it uses components available from an electronic shop with a budget of less than $600. I will now walk you through the basics of an inverter. This is the simplified circuit of a typical inverter. The first important part is the DC power supply. One particular thing about inverter is that they do not produce power. Instead, the power is produced by the DC voltage source. Therefore, choosing a suitable DC power supply is essential for keeping the whole system at an appropriate power rating. The second part about an inverter circuit is a switching circuit. Inverter typically use high frequency switching transistors such as MOSFET or IGBT to get the positive aspect of an AC signal. The current flow from switch number 1 through a load back to switch number 4 before going back to the negative terminal of the DC supply. To get the negative side of an AC voltage, the current first goes through switch number 2 through a load, then back to switch number 3 before going back to the positive terminal of the DC power supply. The final part of an inverter consists of a filtering inductor and a filtering capacitor. These are used to suppress noise, overshoots, and voltage spikes in our output waveform. Knowing the basics of an inverter, I will now walk you through our implementation of our hardware. So this is our hardware implementation. The middle part is our switching circuit. The switching circuit consists of two Semicron high power IGBT modules. Each module consists of two IGBT switches in half bridge configurations. This module can work at 1200 volts and outputting a current of 200 amps, combining that giving us a total power of 240,000 watts, which is more than enough.